Hi, this is Synthchaser from synthchaser.com, here with the mighty and massive Rhodes Chroma. This was the last synthesizer developed by ARP before it went under. Its assets were sold off to CBS, which then released this as the Fender Rhodes Chroma. I've picked up a couple broken chromas, and since I found a good home for this one, it's time to get it ready to make music again. The gentleman I bought this one from said it was working, but then it sat unused for over a decade and wouldn't awaken from its long slumber. He told me he thinks the power supply is bad, so the goal of this video is going to be to get this chroma up and running and making sound. This will probably be the first of several videos I make during the course of restoring and upgrading this chroma. But in my last video we were going to do the same thing with the memory moog that I bought that was supposed to be broken, and it turned out there was absolutely nothing wrong with it. So we're going to try to fire up this chroma and see if it's really broken before we dive in. And I see lights flickering strangely and not much going on. I'm going to turn this off before things get really hosed. But yeah, it looks like I'm not going to be as lucky with this chroma as I was with the memory moog. So let's get this beast open and dive in. Here it is opened up, and to my great relief, all 8 of the voice cards are there. So I'll take you around the back and I'll give you a quick tour of what's inside the Rhodes Chroma. The Rhodes Chroma is an 8-voice synthesizer, so there's 8 voice cards. And they're seated on this voice card motherboard. And they kind of just sit into the little slots, and they have these little red connectors which connect it to the motherboard. Kind of like a PCI card on a computer. In the back left here we have the power supply, so there's a large transformer, a big filter capacitor, some other capacitors down there, and transistors mounted on the heatsink on the back of the case. Power comes in here through this line filter, there's the power switch, and there's the main fuse. And we don't need to check that since we saw stuff on the control panel lighting up, so we know the fuse is good. But what we'll do is we'll come back here and we'll disconnect these connectors to the power supply, and we'll test the voltages on the power supply. But let's finish our look around the synthesizer first. So the keys, they're nice wooden keys, and when you press one, you can see here it actually uses a mechanical leaf switch that opens and closes, and it's scanned by these 2 boards here. There's 64 keys. Each of these boards, there's 2 of them, scans 32 keys. To get to the remaining circuit boards, we've removed some screws on the left and right of the panel, and we can fold it up like this, and it provides access to the remaining 3 circuit boards which are mounted under the hood. This board on the far right is the CPU board, and it basically just has the CPU chip, the ROMs, and the RAM, and the battery for backup. You can see that there's some battery corrosion. These alkaline batteries were left in there. The battery holder is all corroded, and there's a tiny bit of corrosion working its way down to the circuit board there. So it's a bad idea to leave batteries in synthesizers for long periods of time, because they will leak and they will corrode the board. But aside from the functions of CPU, ROM, RAM, and clock, there's really not much going on this board. So next we have this board, this long board, which is called the I/O board, and this pretty much interfaces the computer board, which we just looked at, with all the analog circuitry of the keyboard. So it has stuff to scan the switch matrix from the buttons that you push on the panel. It scans the keybed matrix. It has an analog to digital converter. It has a digital to analog converter. It drives the LEDs on the control panel. It works the cassette interface and the computer interface, which were the early pre-MIDI input-output interfaces for this synthesizer. And then it has this thing here, which I'll give you a better look at. This is called the tapper, and basically it's a solenoid. It's a coil here. And when it's energized, it drives this little shaft down and up and down, and it makes a tapping noise, so you get some audible feedback when you press a button on the control panel. And then finally over here we have the EQ board. The EQ board has these sliders that give you some control over the output. So So now that we've had a brief look around, let's get this thing up and running. So we're going to start by taking a look at the power supply and see if all our voltages are correct. So I've disconnected these 4 connectors connecting the power supply to the rest of the synthesizer. And the reason that I do that to test the power supply is there could be a short circuit or some other problem somewhere else in the synthesizer that's pulling the voltages down on the power supply. So to test a power supply for basic functionality, we will always disconnect it from the load. So that's what I've done here. And these connectors, the pin out is in the service manual, but you would think that the notched corner is pin 1. Let's see if I can poke it. There, see the notch on the corner, but that's actually not pin 1. So just be careful when you their naming or numbering convention for these pins was a little weird. So just be careful when you probe it that you're looking at the right thing. So I'm going to go ahead and turn this on, and we're going to probe this power supply. I hear a little buzz coming. Is it coming from the transformer? Yeah, I guess coming from the transformer. So let's start with this connector here. This is P2, and we are going to be looking for the digital 5-volt supply that's used by the CPU board. So there's a digital ground, which is this pin here, which is pin 1, and there is plus 5D digital, which is pin 2. And our voltage is actually 2.05 and slowly dropping. So we definitely have a problem with the 5-volt digital rail. Let's check some of the other supplies. So that tapper uses basically just an unregulated 24 volts. So the tapper ground is on this connector still pin 6, and the tapper positive supply is on pin 3. It should be about 24 volts, and it's 24.5, which is fine. So this connector is the 5-volt digital and the tapper, and we have a problem with the 5-volt rail. Tapper is okay. So next one we're going to look at is this one right here, and this one has our analog voltages. So we'll put our common lead here on this pin, which is the analog ground, and we'll start by taking a look at the 5-volt analog rail, which is this pin 2, and we're at 5.075 volts, so that's okay. We'll move to pin 3, which is the minus 12 volts, and if I get, is that pin 3? There we go. Minus 12.2 volts, so that's okay. We'll hop over here to pin 4, 12.21 volts for the positive 12 analog rail, and that's okay. And those are pretty much the rails that we have. These other pins, duplicate those, and there's a reset pin for the CPU that controls the CPU reset line. But if we have 2 volts on our 5-volt rail, the CPU is never going to run anyway. So we actually do have a power supply problem. I doubted that there would be, but there is. So let's dive into it a little deeper and see if we can fix it. So what I noticed right away was this transistor here that's mounted to the top of this large capacitor is burning hot. And since it's kind of just floating here in the air, and well, first of all, there's no load attached anywhere here, so nothing really should be getting hot. But since it's floating here in the air, we should just be able to unscrew this filter capacitor and check this transistor out. So I've taken this off, and it's actually not a transistor, it's a Zener diode, and it's designed, I guess, to drop some of the voltage, prevent the voltage across this capacitor from being too high that it generates a lot of heat on the voltage regulator for the 5-volt line. And you can see underneath, this board is like scorched all the way through from it. So I've just removed it for now, and we'll turn it back on. And that humming, which I thought was the transformer, is gone. It actually was this Zener diode, so there's no more hum. But let's check the 5-volt line now. And we are... Did just see something? We're at 5.073 volts. So the problem apparently was just this this Zener diode, and now we should have all our supplies working. I'll go through and verify again, and then we can connect this stuff back and fire up the synthesizer again. So now that we got 5 volts on the 5-volt digital supply, I reconnected the boards and we're going to fire it up and see what happens. And I saw the lights flicker and they went off. Try this again. This time they're illuminating and they're staying on. So we're still not out of the woods. So since we tested the power supply without the load connected, let's test the power supply with the load connected, make sure we still have 5 volts. It could indicate that we have a short or something down the line, or another problem with the power supplies. Alright, what we're going to do is we're going to try to cram our leads down into this connector here and measure the 5-volt digital with the load connected. So I'll turn the power on and we'll see if we can get in there. There we go. 4.1, basically 4.2, which is not 5 volts. It's too low to run the CPU chip. So that is why things are not working. So let's see if we can adjust this 5-volt supply to get a higher voltage there. So looking at the schematic, I see that there's a trimmer R46, which should allow us to adjust the 5-volt digital rail. But in here, I'm only seeing one trimmer, this one here, which is labeled R22, which I see on the schematic is for the 5-volt analog rail. So I'm going to consult the schematic and the PC board diagram and see if I can figure out where this R46 trimmer is. Well, what do you know? So the R46 trimmer should be right there. And as you see, there is a missing 3-legged component there, which is our 5-volt digital adjustment trimmer. So we're going to have to take this power supply board out and replace this trimmer. So before we take anything out, there is one more thing I want to check, and that's the ESR of the filter capacitor. So we did see that the voltage was low; it wasn't 5 volts, but I did notice that it was creeping up very slowly by, like, a millivolt a second or so. And I just want to make sure before we start doing things that this capacitor is okay. And there's 2 things that you can measure on a capacitor. There's the capacitance, and electrolytic capacitors rarely fail by losing their capacitance. But electrolytic capacitors commonly fail by getting a high ESR. And what ESR is basically there are 2 components to a capacitor, or any component. There's a reactive component and a resistive component. And with these electrolytic capacitors, the resistive element of them can increase over time, and basically it's equivalent to there being a series resistor there that is slowing down the flow of current into this capacitor. And you'll notice it sometimes on like old monitors or TVs that you have to turn on and let them sit for half an hour before they'll turn on, and that's because the ESR in the capacitors has drastically increased. So because this was creeping up slowly, I want to make sure this capacitor is okay. So I have this ESR meter here that I got from China, and it works okay. You can test ESR in series, in circuit, I mean. So what we're going to do is we're going to connect this to the filter capacitor here and measure the ESR. So it says the ESR is 0.13 ohms. There's a little table here which I'll zoom in on. So this little table on the meter gives you the standard worst case electrolytic capacitor ESR. So your ESR, if you find your capacitor on this table, your ESR should be no higher than what's listed here. The capacitor that's in here is a 47,000 microfarad 7.5 volt capacitor. So our table doesn't really cover this case. So the closest we can see is this 10,000 microfarad 10 volt capacitor. So you see, as we move to a lower voltage, the ESR can be a little higher, but as we move towards higher capacitances, the ESR needs to be lower. So you can't really read this table, but if it's okay, it's marginal at best. So maybe what we can do is we can try putting in another capacitor and see if that's our problem. So here I've taken an old capacitor left over from a Prophet 5, and I've connected the wires up to that, just as a test of this theory. So we're putting in a capacitor. It's a lot lower microfarads. The voltage is fine, but the ESR on it is good, and we're going to see if that will get us our 5 volts. Okay, with the temporary capacitor in place, let's turn it on, and the lights are flashing, and we're in, and we have sound. So the problem definitely is the ESR of that main filter capacitor. I don't have a new capacitor that large lying around, so I'm going to have to order it, as well as that large Zener diode that was shorted out. But I think today we accomplished what we set out to do. We got the Chroma booting up and making sound. After the replacement power supply parts come in and I install the permanent fix, I'm going to go over the synth with a fine-tooth comb. And there's also some upgrades I'm going to be making to the synthesizer as well. If you're interested in seeing more of the Rhodes Chroma, let me know in the comments down below. This has been Synthchaser from synthchaser.com. Thanks for watching. Have a happy holidays and best wishes for a great new year.